Hey guys, welcome to my channel Code with Kai, and topic for today is Leetcode number 367 valid perfect squares. Okay, so it is easy, and this is video number 6 of binary search playlist. Given a positive integer num, return true if num is perfect square or false otherwise. So we are basically given a number, let's say 16, and we want to know, is 16 the perfect square. So 4 times 4 is 16, so it is a square of 4. Okay, so square of 4 is 16. What about 14? 14 does not have a perfect square. So we know 3 times 3 is 9. 4 times 4 is 16. Okay, so it lies between this. The number 14 lies between this, so it is not a perfect square. So we are going to return false at that case. Brute force. The brute force that I could think of for this is, let's take a line and let's represent values from as 0, 1, 2, 3, 4, 5, 6, dot till n. Okay, and what I am going to do is, I'm going to, what is my number? Let's say my number was 14. Okay, so I'm going to go at every point and I'm going to ask, is the multiple equal if is the multiple of this same number equals the num. Okay, so I'm going to say, is 0 times 0 equal to 14? The answer is no. 1 times 1 is equal to 14. There is no. So the I point is going to move from here. Then it goes here. Then it goes here. At this point, I'm going to say 2.2 is equal to 14. The answer is no. I pointer is again going to go here. I'm going to ask 3 times 3 is equal to 14. The answer is no. So then I'm going to say 4 times 4. Is it greater? Is it equal to 14? No. Okay, so after that, whatever I do, okay, after 14, whatever I do, my answer cannot exist, because already checked for 16 here. Okay, so now later I'm going to check for 25, then 36. At this point we never got an answer, so after this point we will never get an answer. So what we can essentially do, we can ask two conditions. Is my I that I am checking, okay, is it equal to x? Okay, if it is equal to x, we'll return from that point, return true from that point. Okay, then, or what we can do is, we can say, if I is greater than x, we are going to break out of that loop. Okay, because at this point we must have gotten an answer. Okay, at this point we'll break. If I times I is it if it is greater than x, will break. But if I times I is equal to x, then we are going to return true. Okay, so let's do the coding part of it now. Okay, so let's say we have that number line. So for int I is equal to 0, I less than num I plus plus. If I times I equal num, I'm going to return true at this point, since we found this perfect square. Otherwise I'm going to check if I times I is greater than num. At this point I'm going to break, since we cannot have an answer after that. Okay, and I'm going to return false after it. Okay, since this the multiplication can overflow, I'm going to say long to keep it safe, and I'm going to run the code. Okay, so it is accepted. Let's just submit it. Okay, so wrong answer. So we need to handle scenario where num is less than equal to 2, less than 2. We're going to return num. We have to handle this base case as well. Let's run it. Let's just submit it, and we should pass all the test cases. Yeah, so it works. This solution also beats 100%, but it is not optimal yet. Okay, so let's go to the optimal solution now. Okay, so let's take a look at optimal solution now. That is, by using binary search we can solve this question. So let's understand this using a number line. So we have this number line that is ranging from 0 to 8, and let's apply a binary search on this. Let's say S, and let's take the end pointer as E. So what we are going to do is we are going to simply check, uh, simply take the mid. Okay, mid is equal to S plus E by 2, which is going to be 0 plus 8 by 2, which is going to be 4. Let's take mid as 4, and we are going to simply ask a simple question. We are going to ask a simple question: is whatever is at mid, okay, multiply by itself, okay, mid times mid, that is mid square, is it equal to whatever target we are searching for? Suppose the target we are searching for is 14. Okay, we are going to simply ask the question: is it equal to target? If it is equal to target, we are going to return true at this point. Okay, that means it is a perfect square. Okay, since these number are integers, okay, and if we multiply the same number by itself and we got t, that means we found the answer. Okay, otherwise what can happen is we have two choices. That means the number was either less or more. So we are going to check if the mid times mid is greater than t. That means uh, in this line, if we have mid times mid right here, and this is ranging from 0 to e, 0 to it is ranging from S to E. Okay, and if mid times mid is greater than t, that means t must lie somewhere around here. Okay, t must lie between these range. Okay, that means the right side of this can be excluded, so we are going to place the end pointer right here. Okay, so we can simply say E is equal to mid minus 1. Otherwise it is other way around in binary search. Okay, otherwise we can say S is equal to mid plus 1. So let's write a general definition for this, and I'll move this code. Okay, and if you are not able to find answer even after doing this, we are going to simply return false. Okay, so there is a loop that goes from 0 till n. Okay, that is I is equal to 0 till n. We are going to calculate mid. So we will calculate mid at this point, and if the mid times mid is equal to the target that we are looking for, we are going to return true. Then we are going to do the exclude part of the binary search, and then we are going to return false. Okay, so let's do dry run on this. So we found mid. The mid was 4, so 4 times 4 is equal to 14. So the t that we are want to search is 14. Just write at top right. So the answer is no. So it will go to the, so this is false. So it's going to ask a simple thing: is it greater than 14? Is the mid greater than 14? The answer is yes, it is. So I'm going to take the end pointer and move to mid minus 1. So I'll just go to take the end pointer and move it to mid minus 1. So this is where the end pointer will be. The right side will be excluded at this point. Okay, right side is excluded and end pointer is set. Then I'll continue the search. So let's go to the iteration number 2. Let's calculate mid again. Mid is going to 0 plus 3 by 2. Mid is going to be 1 at this point. Now I'm going to ask a question: So this is what the mid is. Okay, have we found the answer yet? Is mid times mid equal 14? That is what I'm going to ask. Okay, it is equal to target. The answer is no. Since the mid is 1 times 1 is equal to 14, the answer is false. Then I'm going to ask a simple question again. Is my mid times mid greater than target? Okay, so is 1 times 1 greater than 14? The answer is no. Okay, so the else part of this block will be executed now. The else part will be executed, and it is going to set s is equal to mid plus 1. So we cannot find the answer on the left side of it. So the left side is excluded. It is going to move the s pointer right here. Okay, so I'll calculate mid again. Mid is equal to what is my s? My s is 2 plus 3 by 2. Since the answer is going to be 5 by 2 is going to be 2. Okay, and I'm going to ask again, is my mid times mid equal to target? The answer is no, it is not. So we are going to return so we are going to check for the next condition, that is this condition. So we are going to check for this condition. Okay, so is my mid times mid greater than target? Okay, so my mid is 2. So is 2 times 2 greater than 14? The answer is no. Okay, if the answer is no, it is again going to go to the else part of it, and the s pointer will move to mid plus 1. Okay, so the mid was again pointing at right here, so s pointer is going to go to mid plus 1. So this is where the s pointer will be. Okay, so now the s pointer and e pointer both are pointing at same point. Okay, so let's do mid calculation again. Mid is equal to 3 plus 3 by 2, that is going to be 3. So once we have mid, I'm going to ask again, is 3 times 3 equal to 14? The answer is no. Then I'm going to ask, is 3 times 3 greater than 14? The answer is no. Okay, so it is again going to go to the else part. So I'm going to ask, I'm going to set s is equal to mid plus 1. Where is my mid? Mid was calculated and it is also pointing at the same point. So I have to increment the s pointer to mid plus 1. So it is s is going to point to the fourth index now. Okay, so this is where the s is going to point. Okay, let me write. S was previously 3 and was previously 3. Now s is going to point to mid plus 1. Okay, so what was my mid? The calculated mid was 3. So it is going to be mid plus 1. S is going to point to 4 now. Okay, so S is not going to point to 3, S is going to point to 4 now. At this point, when S is greater than E, okay, a binary search will stop. Okay, the binary search will stop. And if we have not found the answer yet, we are going to simply return false. We have not found the answer, we are going to return false. Let's take another example where the target that we want to find is 4. And so this is my S pointer pointing at, this is my S pointer, and this is my E pointer, end pointer. Okay, so what we want to do is we want to first calculate the mid. For iteration number 1, S plus E by 2 is going to be 0 plus 5 by 2 is going to be 2. So this is where the mid is pointing at. Okay, so previously remember we had this condition, if mid times mid is equal to target. Okay, we were going to return true. So we found the target, so we are going to return true at this point. So this part of the code will never get executed since we returned from this point only. Okay, so what is my mid? My mid is 2 times 2. Is it equal to the target? The answer is yes, it is equal to target. So we are simply going to return true. Okay, so let's see the code of this now. So let's begin. Int s is equal to 0, int e is equal to num, and we are going to go while s is less than equal to e, and we're going to calculate mid. Mid is equal to s plus e minus s by 2. This is the safe way to find mid. Okay, you can refer video number 2 for this for more. Okay, so if mid times mid equal num, that is the target, I'm going to return true. Otherwise, I'm going to do a simple check if mid times mid is greater than target, that is num. Okay, I'm going to say end is equal to mid minus 1, else s is equal to mid plus 1. Okay, and I'm going to return false if we have not found the answer yet. So let's just run it. So it is accepted. Let's just submit it. I think it will break at this point. Yeah, since we cannot multiply two larger numbers, store the answer in the integer. We have to do long. I'm going to timecast this calculation. So run it and let's submit it. I think it will still break. Let's see. Yeah, okay, it passes all test cases, so this solution works. Okay, so that is it for the video. Bye. If you like my video, please subscribe. Thank you.